Okay, so we're going to have a quiz tomorrow. So we're just going to do a little quick review for that. Yeah. Hi, everybody out there in TV land. Hang on just a second, though, is this our... all right, so we are going to have a little quiz tomorrow, like I said. So what we're going to go through, if you guys would get out a piece of paper, and we'll go through some of these questions together. I'm going to try to get you to do most of them on your own, and then we'll go through the answers just to make sure, okay? So will you right now do these first 6, well, why don't you do the first 3 problems first on your own, and then we will. So what we decided 4th period is you can use this on your quiz tomorrow, okay? So that's one incentive for doing it. And then they talked me into a little extra credit action if you turn it in with the quiz, okay?
Oh, you turn it in. Oh.
Yeah, so, okay? So that's what we got going. All right, so do the first 3 on your own. Let's go to Madeline. What are the first 5 terms in number 1? Huh? Well, you should be. Oh, okay. All right, what you got?
16.
What? 16 is the answer to number 1? Well, that's the 5th term. Okay, they want the first 5. So I was a little worried there. I was like, okay, she has no idea what we're doing. Okay, so 4, 7, 10, 13, and then 16. Awesome. Okay. How about the second one? Anybody get that? -3, -5, -7, -9, -11. Okay, perfect. And then the third one is a little bit trickier. How do we find out this? Avin, will you tell Carla how you got that? Your answer for number 2? Two, 8. Oh, it's what? Oh, so if you plug in 1, 1 squared is 1, plus 2 is 3. Then if you plug in 2, 4 plus 4 is 8. Then you have to plug in 3, so you get 15. Because 3 squared is 9, 2 times 3 is 6, 9 plus 6 is 15. And then once you do a little of them, then you can see the pattern and it's easier. So this was plus 5, then plus 7. Oh, okay. So you were looking at this one. Oh, I see. So you got that right there. Okay, so plus 5, then plus 7, then plus 9 would make this be 24. And then plus 11 makes this 35. Okay? Okay, so then the next 3 are a little bit different. These are the recursive formulas. So it's always telling you what to do to get the next thing. So for this one, you want to start at 2. And then this right here, 3 times a to the n minus 1 means take the one before it and multiply by 3. So if I start with 2, the next one's going to be just multiply by 3. Yeah, so 2 times 3 is 6, and then, which is 18, and then, which is 54, and then 54 times 3, which is 162. Okay? Does that make sense? So that's an easy one. This one now is a little bit confusing because what this is saying is to get the next term in the sequence, go 5 minus the one before it. Okay? So I'm going to start with 1, and then how do I get the next term? 5 minus 1, which is 4. And then to get the next term, I go 5 minus 4. Yeah, which is 1. And then 5 minus 1, which is 4 again. And then 5 minus 4, which is 1. Okay? Yeah, that is tricky. So I'm starting with 1. Okay? So then to get this one right here, I go 5 minus the last number that I did, which is 1. Yep, yep, exactly right. So the numbers I keep getting, I just plug them into the formula for the next thing. Okay. Okay, and then 6 is the trickiest of all. We're going to start with 1 again. But then this time it says, take the number that you just got, and then add 2 times n onto that. So this term right here that I'm looking for is which term? The second, so that means n is 2. So 2 times 2 is 4, right? So then I add 4 onto 1 and get 5. Okay? This term right here is the third term. 2 times 3 is 6. So Evan, I'm not adding 6 to 1, I'm adding 6 to the one that I just did. Yeah, so 6 plus 5 is 11. So it's always built on the one, the answer that you just got. The next one is 19. Because this is the fourth term that we're looking for. Yeah, 4 times 2 is 8. And then if I go 11 plus 8, then I get 19. And then the next one is the fifth term. So 29, yeah. Okay? Rachel, you okay?
Yeah.
You look a little unhappy. You don't need to apologize. Oh, you can't see. Is there glare or? Okay. Okay, so next one it says write a recursive definition for each sequence. So these are the, we have, I don't know, till it's time to go problems. Okay, so when you guys look at 2, -4, 8, -16, what do you're multiplying by -2. So the question is, Madeline, do you know how to write that out? Okay? Okay, and if it's a recursive formula, you're always starting with a sub n equals, and then you're going to have the a sub n minus 1. Because this is like if I'm looking for the fifth term, then I take the fourth term, right, the one before it, that's what minus 1 is, and multiply it by, no, what am I doing in this one? Multiplying it by -2, yeah. So it'd be -2 times a to the n minus 1. Because 2 times -2 is -4, -4 times -2 is 8, and 8 times -2 is -16. So that's the pattern. I'm multiplying by -2 each time. Okay? So Bailey, you can take the next one because it's an easy one. What's the pattern? So the pattern on this one, Bailey, is add 3 each time. You can see that, right? So the way you would write that as a formula is a sub n minus 1 plus 3. Because it's kind of like writing y equals when you're like writing an equation or something. That's what Avin was asking. So like if you want to find the sixth term, n would be 6, right? So then if I put 6 in here, then 6 minus 1 is 5. So this is just a way to show that I want the one before it always. Just smile and wave. Yeah, perfect. Avin? Yeah. Right. Okay. The sixth term plus 3 gives you the seventh term. Yeah, exactly. Okay, good. Right. Okay. Okay, now number 9 is a tricky one. And I'm going to show this to you. And let's see. Maybe 6 or 7 of you are going to go, oh, okay, got this. Okay, so the problem here is that you're going down 2, and then you're going up 3, and then you're going down 4, and then you're going up 5. Okay, so there's obviously a pattern there, but it's switching back and forth from positive to negative. Okay, so the way this goes is, what we're doing is we're taking the term before it, okay, and you're adding onto their n. Okay, so to get the, yeah, Gage has got it. So to get the second term, I add 2. To get the third term, I'm adding 3. To get the fourth term, I'm adding 4. But you guys are saying, wait, no, you're not adding. You're subtracting every other one, right? So the way that I get this to bounce back and forth between adding and subtracting, this is the part part of this problem, is I'm going to go to the negative 1 to the nth power. Because if this is even, it'll make this be 1, and if this is odd, it'll make it be negative 1. So it'll be, then I would go to the n minus 1 power, so it would jump around. Yeah, yeah. Well, then, so then they'd have to give us a starting point. Okay? Okay, so it starts with 3. Then to get the next one, what I do is I take the one before it, which is 3, plus n, and so I'm looking for the second term, so now n is 2, right? 2 times negative 1 to the, if I plug 2 in there, that's 1. So negative 1 to the first is negative 1. So then that would make this into negative 2. So I would subtract 2 and get 1. Okay. Then for the next one, I say, okay, take the 1 that you just got. Now n is 3, right? So negative 1, well, this is going to end up being 2. Negative 1 squared is 1. So then I'm going to end up adding 3. So that's going to give me 4. Okay. So, I don't know. Like I said, hopefully 5, 6, 7 of you sort of understand that. That's okay. Okay. I wouldn't lose any sleep over it. All right. So this is kind of funky because technically these problems are from section 9.1. So we didn't learn yet the formula for an explicit sequence that is multiplying each time. So you guys know this now. What are you multiplying by each time? 2. So you can say that the formula is going to be 2, because that's the first term, times 2, because that's the common ratio. It's just a quinky-dink that these are the same, to the, no, because we're going explicit. So right, to the n minus 1. Okay, so you can use the thing that we learned yesterday to figure out this formula. But if you didn't know this formula, can anyone see what it would be? That just means, Carla, if I'm going to try to find like the 6th term, I go 2 to the 5th power. I do 1 less than the term that I'm trying to find. Does anybody see what this would be if you didn't know that formula? Kelsey? No? Okay. Peyton? Oh, no, it's not parabolas. Okay, so you don't get it. Okay, that's all right. What did you just say? No, totally off? Okay. It actually turns out to be a sub n equals 2 to the nth power. So this is 2 to the first, 2 to the second, 2 to the third, and 2 to the fourth. Okay? And that's what this would simplify to, because the bases are the same, so you add the exponents, and 1 plus n minus 1 is just n. So Chawfield. Okay. Okay, number 11, this is a, what kind of? Arithmetic sequence, okay. So we know the formula for that. Going down by 3. So that's, we're going to use that, but before we do that, what do we need in the? Nope, because that's the recursive again. So I need the first term, good, which is 5. And then this is always plus n minus 1, just like this is always to the n minus 1 power, times the common difference, which Gage said was negative 3. Nice job, Gage. You're huge in Japan right now. You are an internet sensation.
Don't forget Australia.
Yeah.
And I saw
Bahrain.
Bahrain.
Yeah. Shout out to all of my homies in Indonesia. Okay, so how about number 12? Right, so this is, you're going up by 3, then 5 by 7. So the first difference isn't the same, but the second difference is, right? Those are all going up by 2. So that's a clue that it's going to be a squared situation. All right? Well, 1 squared is 1. 2 squared is 4. 3 squared, yeah. So these are all 1 more than the perfect square numbers. So the formula is n squared plus 1. Q. What's 1 squared? Plus 1 is? What's 2 squared? Plus 1 is? Got it? Okay. Okay, rolling right along. Okay, so now we're fully into the arithmetic sequence situation here. So all of these are arithmetic sequences. So we need to find the 9th and the 10th terms. So do you want to just keep adding, or do you want to use the formula? Use the formula? Okay, so for 13, the formula is, Kaylee, don't let us down now. It's going up by 7 each time, so the formula is, it's an arithmetic sequence. You got this. I know you weren't paying attention. That's why I called on you. You got us in the last one. Okay, so it's the first term, which is 1. Yeah, okay, so then you just have to plug in 9 and then plug in 10. So I will let you do that on your own. And you can confirm that answer with someone sitting next to you if you're not really 100% sure. Unless you're Kyler, who's all by himself in the back today. No friends. What you got? Okay. 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 1/2, 1/4, 1/6, 1/8. Okay. Not geometric, because it's not multiplying by the same thing each time. Okay, 1/2 times 1/2 is 1/4. But then if you go 1/4 times 1/2, you get 1/8, not 1/6. Okay? Okay, were you guys able to get 9 and 10, the 9th term and the 10th term on your own? Okay, Carly, you got to plug in 9 here. Okay, so 9 minus 1 is what? 8. 8 times 7 is 56, and 56 plus 1 is 57. Okay, same dealio with 10. If I plug 10 into there, 10 minus 1 is 9. 9 times 7 is, and 63 plus 1 is, okay. Because it said find the 9th and the 10th terms, okay? All right, someone besides Kaylee want to give us the explicit form? We did, that's how we got this one right here, okay? Someone besides Kaylee want to find the explicit formula for number 14? It's going up by what? Going up by 6. No, because it's going up by the same amount each time. That's arithmetic. If it's multiplying by the same amount, that's geometric. Okay? Go, Bailey. Go, Bailey. It's your birthday. No? Yeah, this one right here, remember we took the first term. Uh-huh. The last thing is going to be a 6, but what goes in front of that? Awesome. Okay, so Carla, now you can do this on your own. Plug in 9 and then plug in 10 and figure out what you get. Do you want to do 15? Or are we okay with all this? You can do 15 on your own, maybe? You got it? Okay. Do 15 on your own real quick thing. Okay, these 4 are about as easy as math problems as you would ever want to get. Determine whether each sequence is arithmetic. If so, identify the common difference. So 1, 3, 9, 27, arithmetic, yes or no? No, you are not adding the same amount each time. So that is a big fat no, and then you are done. How about number 17? Yes. And what's the common difference? 11. How about number 18? Yes. And what are you adding each time? Right, if you're adding the same amount each time, Carla, then it is arithmetic. Right, and this is -2, and then this guy right here would be no, because this is +2, then +3, then +4, then +5. Then it is not arithmetic, then it's geometric. Yeah, only works for adding. What's that? Because you're multiplying by 3 each time. No, going up by 11. Caught yourself. Nice job. 16, you're right, is geometric, yeah. Right. Yes. Huh? Yeah. Well, or subtract. Add or subtract, yeah. Okay, then for these, we did these last night with geometric sequences where you had to multiply them together and then take the square root. If it's an arithmetic sequence, how do you find it? Add it together and divide by 2. So 3 plus 17 is 20, and half of that is 10. 25 plus -15 is 10, and half of that is 5. -3 plus 8 is 5, and half of that is 2.5. And then 66 plus 48 is 114, so it's 57. It says 2.5, yeah. So Carla, the reason why that works is because 3 plus 7 is 10, and then 10 plus 7 is 17. So it fits in that pattern. It fills in the missing slot. Okay, and then when we get to these, it's a little bit more detailed because there's 3 of them. So there's 2 different ways that you can do these. You can do what we just did to find the middle missing term, and then do that between these 2 to find A2, and then do that between these 2 to find A4, or we can do the step thingy. Which one do you like? You want to do the step thingies a little bit faster? Okay, so for number 24, how far is it from 4 to 32? A total of 28. This is the hard part. A lot of times students look at this and say, oh, I'm taking 3 steps, but there's actually taking 4. Yeah, 1, 2, 3, 4. So I have to divide that by 4. So 28 divided by 4 is 7. So that means my common difference is 7. Okay? So 4 plus 7 makes 11, and then 18, and then 25. And you can always check your work on these. That's what's kind of nice, because I went 11 plus 7, because 25 plus 7 is 32, so that means that it works. Okay? The 28 came from 32 minus 4. Let's do that again for number 25. So, Carlita, from 10 all the way to -20 is down how much? 30. Okay, so that's -30. How many steps do I want to take between 10 and what? 4. Okay, so I'm going to divide that by 4. So that gives us a decimal, but we're big kids, we can handle that. -7.5. All right. So that means to get these missing terms, you just subtract 7.5 each time. Do you have your phone? Oh, it's dead. That's why you're asking so many questions. Awesome. All right, so 10 minus 7.5 is 2.5. 2.5 minus 7.5 is -5. -5 minus 7.5 is -12.5, and then if you do that one more time, you get to -20. All right? Okay, so we're just about out of time, so you can try, what? Oh, yeah, for 26, yeah. So do 26 on your own, finish that up, and that will do it. Okay? Yep. So big, fat, fun quiz tomorrow.